Hey guys, welcome back to another video. Today I will be covering Chapter 16 of the Environmental and Natural Resource Economics video series. This will be the last chapter that I am covering in this course. A lot of curriculums, especially at the university level, they don't go beyond Chapter 16. There are some more advanced classes, but I'm not sure if there's enough demand. So right away, if you guys feel that you need more videos, please comment below and let me know that, I need more videos and I'll be sure to make more. But usually this is where I've spoken to a few other students who are at other schools and who are doing this course, and usually majority of them stop at 16, so I don't want to go further if they're not going to be used. If you need them, please do comment below, and if I get enough kind of support, then I will continue the series up until the end of the book, and I believe there are about 20 chapters, so there's still a few more videos that I could make. But let's get started. So in Chapter 16, we're going to be applying what we learned in Chapter 14 with regards to pollution, and we'll be kind of looking at different policy responses and the things that developed countries and the world has already done and taken action against. So, as pollutants flow beyond local boundaries, the political difficulties of implementing comprehensive, cost-effective control measures are compounded. Pollutants crossing boundaries impose external costs. Neither emitters nor the political jurisdictions within which they emit have the proper incentives for controlling them. And that essentially means that, it would be so easy to assume that, okay, if I pollute X amount in my country, and that pollution and that smog is going to stay in my country. It doesn't. It drifts. It goes into the atmosphere, and then it impacts the world as a whole. So there's an implicit externality when you're talking about pollution, because if you pollute in your country, it just doesn't affect your country. It affects the global economy. And so right away, you're not really fully valuing that pollution. So the costs of inaction are not limited to the damages caused. International cooperation, such as traditional allies as the United States, Mexico, and Canada, and the countries of Europe, have been undermined by disputes over the proper control of transboundary pollution. So really, who's pointing the finger at who and who's saying, oh, it's your fault, you're polluting more than me, and because of that, you should be paying more. At the end of the day, you're still polluting. Everyone's still polluting. We should all take part and share in the joint action of combating pollution. So, a quick science of climate change. If you've watched, the Al Gore documentary, then it shouldn't be too hard to understand. But evidence is mounting that by burning fossil fuels, leveling tropical forests, and injecting more of the other greenhouse gases into the atmosphere, humans are creating a thermal blanket capable of trapping enough heat to raise the temperature of the Earth's surface. So when the sunlight passes through the atmosphere, some of it is absorbed by the Earth and some of it is reflected back, and it's supposed to go out into space, but some of it remains trapped and kind of bounces back towards Earth because of that thickening of the atmosphere due to greenhouse gases. Now, the Intergovernmental Panel on Climate Change, the IPCC, suggests increases in carbon dioxide concentration are due primarily to fossil fuel use and land use change, while those of methane and nitrous oxide are due primarily to agriculture. The warming of the climate system is unequivocal, so there's no dispute over the fact that the climate is warming up and global warming is real, except if you're a Republican and you don't know how to read a science book. And the projected impacts of the warming include contracting snow cover, shrinking sea ice in the Arctic and Antarctic regions, and increasing weather events such as extreme heat, heavy precipitation, and intense storms. Now, recently, scientists have also uncovered evidence to suggest that climate change may occur rather more abruptly than previously thought. An example that raises this concern is the methane trapped in the frozen tundra of the north. Large quantities of methane gas lie trapped in the frozen tundra. As temperatures warm, the tundra can thaw, releasing the trapped methane. And so that accelerates the global warming effect. It accelerates the amount of greenhouse gases that are released in the atmosphere. So really, when we talk about projecting the overall increase in greenhouse gases, majority of the models that were initially created were far too off the mark. They undersold and undershot what really greenhouse gases are projected to be like. Any action taken to moderate climate change provides a global public good, implying the strong possibility of free rider actions. Those who do not control greenhouse gases cannot be prevented from reaping the benefits of the actions of those who do. And so this complicates things. Free rider effects not only cause emissions to be abnormally high, but they also inhibit investment in research and development. And unlike a normal marketed good, the scarcity of a stable, hospitable climate is not signaled by rising prices for that good. So, you can't really price Earth. There's no market price where people trade it. Like at the end of the day, Earth is Earth. And for that reason, there's a lack of clarity of, is the value of Earth overall and the health of the environment increasing or decreasing? And so when there's that lack of clarity, in addition to the free rider effects, which occur when you have developed markets who don't give a shit about the environment, and you have developing markets who just ignore the restrictions that are placed on them. Well, then that's a free rider that just worsens the problem. Now, to further complicate matters, the damage caused by greenhouse pollutants is an externality in both space and time. Spatially, the largest emitters have the greatest capacity to reduce emissions. Temporally, the cost of controlling greenhouse gases fall on current generations, while the benefits from controlling them occur well into the future, making it more difficult to convince members of the current generation to join the mitigation effort. So essentially, you incur, our generation, this generation today, the people who are living, are going to incur a lot of the costs, whereas the future generations will really see much more of the benefits. So we have to suffer in order for our future generations to, A, have a hospitable climate, and B, benefit from our actions. So it doesn't make sense from a pure economic perspective, and that's why there's a lot of challenges and pushback. Now, what can be done? There are three strategies. There's climate engineering, also known as geoengineering. There's adaptation, and there's mitigation. And right away, I'll tell you that mitigation is really the proposed solution, and it is what this chapter will really cover. Now, climate engineering can be divided into two very different categories: carbon dioxide removal and solar radiation management. While approaches in the former category, such as direct air capture or ocean fertilization, seek to reduce the greenhouse gases, approaches in the second category, such as injecting stratospheric aerosols, aim to cool the planet by reflecting a fraction of the incoming sunlight away from Earth. So playing around from a scientific perspective and trying to, protect the Earth's stratosphere is slightly effective, but not truly as effective as people are suggesting it to be. So this is a very simplified example of direct air capture, where you suck in the air and you have your CO2-rich solution with a lot of energy. You're pushing out that CO2 that exists, and you're pushing out the clean CO2, and you're taking that solution, that capture solution with all the different chemicals, and you're removing that from the atmosphere. There's adaptation, which strategies involve efforts to modify natural or human systems in order to minimize harm from climate change impacts. Examples include modifying development planning to include the impacts of sea level rise and preparing public health facilities to handle the consequences of the changing disease impacts of a warmer climate. This essentially says that, okay, we've accepted that global warming is here, we're just getting ready to survive. And that's not really realistic. You want to make sure that you're taking actions to protect the environment, and that is mitigation. Mitigation attempts to moderate the temperature rise by using strategies designed to reduce emissions or increase the planet's natural capacity to absorb greenhouse gases. The most significant mitigation strategy deals with our use of fossil fuel energy. Any serious reduction in carbon dioxide emissions would involve significant changes in our energy consumption patterns and could have a high economic cost. In the stratosphere, so now we'll talk about actually the precedent. So before the greenhouse gases, the big worry was, the ozone layer and ozone-depleting gases that came from different aerosols. And so just to give you a quick example of how the world reacted to this crisis, because the greenhouse crisis kind of started in the 2000s, whereas the ozone depleting crisis probably started in the mid 1990s. So in the stratosphere, the portion of the atmosphere lying just above the troposphere, rather small amounts of ozone present have a crucial positive role to play in determining the quality of life on the planet. In particular, by absorbing the ultraviolet wavelengths, stratospheric ozone shields people, plants, and animals from harmful radiation. So essentially, you have this ozone layer between the troposphere and the stratosphere, where it protects from the radiation that comes from the UV rays from the sun. And essentially back in the day, you had aerosols and different gases that were depleting that ozone layer. And so more radiation was entering, and there was direct correlation to increased amount of cancer in certain areas of the world, especially who are getting much more sunlight, so closer to the equator. And so the CFCs, which are greenhouse gases, also deplete the stratospheric ozone shield as a result of a complicated series of chemical reactions. The major known effect of the increased ultraviolet radiation resulting from tropospheric ozone depletion is an increase in skin cancer. Now, responding to the ozone depletion threat, an initial group of 24 nations signed the Montreal Protocol in September 1988. A series of new agreements followed that generally broadened the number of covered substances and established specific schedules for phasing out their production and use. Part of the reason for the success of this approach was an early recognition of the importance of the need to solicit the active participation of developing countries. Another important aspect involved the creation of the Multilateral Fund. So, as we were talking about with, why, maybe developing countries may not be on board, why they have to, incur all of these costs, while the developed markets in relative terms will not incur as much costs. That's why, the success and the reason why the Montreal Protocol really helped in reducing these ozone depleting gases was simply because they recognize we need to work together with the developing market, and we need to compensate them. Now, to compensate them, in the 1990s, the parties agreed to establish the Multilateral Fund, which was designed to cover the incremental costs that developing countries incurred as a result of taking action to eliminate the production and use of ozone-depleting chemicals. As of July 2008, the contributions made to the Multilateral Fund by some 49 industrial countries totaled more than $2.4 billion. So the fund recognized those developing countries which would incur these costs, and it would compensate them for that change. The existence of the Multilateral Fund, however, does not deserve all the credit for the success of the Montreal Protocol. The success of ozone protection has been possible in no small measure because producers were able to develop and commercialize alternatives to the ozone-depleting chemicals. Countries and producers ended the use of CFCs faster and cheaper than was originally anticipated due to the availability of substitutes. And this is largely probably one of the most important takeaways from why the Montreal Protocol was such a success. The Multilateral Fund and its $2 billion fund, it kind of covered the incremental costs, but the substitute, the availability of a lot of producers to be able to switch to, a cheaper alternative that was even less environmentally impactful was the big reason. And so we talked about in Chapter 6, where you have a depletable resource and you eventually switch to a new renewable resource. That ability to switch to a substitute is incredibly important in any type of capacity, especially when you're designing policy. Now, when considering the mitigation strategy, there are two key policy choices. There's a carbon tax, which is very popular in Europe, and there's a cap-and-trade program in the US. Designing a carbon tax could be particularly simple in the climate change case. Because greenhouse gases are uniformly mixed pollutants, a uniform per-unit charge imposed on all emissions sources would be effective. And putting a tax on pollution could be expected not only to encourage new, more environmentally technologies, but also raise significant revenue. Now, concerns about carbon taxes and the reasons why, Americans don't favor it as much is that it became clear that the amount of revenue collected from these taxes would be very large. The concept of taxes imposed by several international authorities who would then have control over all that revenue was soon replaced by the concept of relying on harmonized national taxes where the revenue would stay in the nation that it was collected in. Now, those concerns were not enough, and eventually concerns over the magnitude and distribution of the revenue were soon joined by concerns over the consequences of participating in a system that taxed only some of the parties. So not only the argument against the carbon tax is not only, there's going to be a lot of tax that's going to be paid because there's a lot of people who admit pollution, right? Where's that money going? But also B, not everyone's on the system. For the system to truly be efficient and for it to work, everyone has to be paying the tax, even those in developing markets. Leakage can occur when tax producers try to pass on their additional costs to consumers. If consumers have the choice of importing goods from producers in nations with no emission charges, they are inclined to favor those imports over the domestic tax products because they are likely to cost less. Meanwhile, producers in the taxed nations, once they notice their market share being eroded by competitors in the untaxed nations, have an incentive to relocate their production facilities to the untaxed nations to take advantage of the lower costs. That's just business. You're focusing on the bottom line. And so if there are nations where, this carbon tax is not present, then a lot of people are going to migrate to those areas in order to take advantage of the lower cost opportunity. Now, post the Montreal Protocol was the Kyoto Protocol, which became effective in February of 2005. It defines a 5-year commitment period between 2008 and 2012 for meeting the individual country emissions target. Okay, collectively, if fulfilled, these targets would represent a 5% reduction in annual average emissions below 1990 levels for the participating parties. And so these were this was a report and an illustration by Allianz Bank, illustrating, the emissions targets for the selected countries. So, Canada, relative to its 1990 levels, had to drop by 6%, the U.S. by 7%. In Iceland, there are some countries that benefited from the date, and we'll actually talk about the controversy surrounding that, because, the Kyoto Protocol started with, okay, we're gonna try to get to 1990 levels. We're gonna look at those 1990 levels and cut by 5% there. So, if Australia had higher emission levels in 1990 than they do now, then they don't really have to cut anymore because they're already below that level, right? So the Kyoto Protocol authorizes 3 cooperative implementation mechanisms. So it can be split, and this is really important to understand, into 3 different programs. So there's the emissions trading, which is a cap and trade policy, which allows trading of assigned amounts. There's the joint implementation. It's a program where Annex B countries can receive emissions reduction credits when they help to finance specific projects that reduce net emissions domestically. And there's also the Clean Development Mechanism, the CDM, which enables Annex B parties to finance emission reduction projects in non-Annex B countries and receive certified emission reduction, so CERs. Now, what does this mean? So the emissions trading, the ET is a cap and trade program. The JI, the joint implementation, is an incentive to finance emission reduction projects domestically, and the CDM, the Clean Development Mechanism, is an incentive to finance emission reduction projects in foreign markets. So, one country, a developed country, probably goes to a developing country that doesn't really have the financing and says, hey, I'm going to help you build this project. And then, of course, they get the CERs, the certified emission reduction credits, right? So the largest and most important of the existing programs is the cap and trade, so the EI, the ET, the emissions trading program. Which was developed by the European Union to facilitate implementation of the Kyoto Protocol. The CDM provides a means for motivating industrial countries or individual companies to invest in projects in the developing countries that result in reductions of greenhouse gases. The incentive to invest is provided by the fact that investors can receive credit for the reductions that are additional to reductions that would have been achieved without the project. Now, there are some complementary strategies alongside the Kyoto Protocol. Given the problems associated with identifying promising projects, quantifying the magnitude of the reductions, and monitoring the results, some means of reducing those barriers were clearly called for. And so there's the Prototype Carbon Fund, the PCF, and the Global Environmental Facility, so the GEF. Now, the Prototype Carbon Fund, think of the fund, so think of fund as mutual fund. This is a environmental mutual fund. It was established in 1999 by the World Bank to serve as an intermediary for encouraging CDM reductions in greenhouse gases. So once again, going back to this, CDM is Clean Development Mechanisms. So you're financing a project, you as a developed country or someone who's cash rich, financing a project in a foreign market. And so, it is that intermediary. And the PCF, which acts as a kind of greenhouse gas mutual fund, invests contributions made by companies and governments in projects designed to produce emission reductions that are consistent with the Kyoto Protocol. The Global Environmental Facility, the GEF, has begun to play an important role in funding deserving projects. So it's not something that invests directly in projects, but rather compensates countries. So the GEF compensates, developing countries that incur incremental costs. So recognizing that many projects have benefits that flow beyond national borders and that individual nations are unlikely to consider those global benefits, the GEF picks up the marginal external costs, the costs that cannot be justified domestically, but could be justified internationally. For example, suppose building a coal-fired power plant is the cheapest way for China to provide electricity to its people, but a slightly more expensive wind power plant would result in substantially lower carbon dioxide emissions. Since the benefits from lower carbon dioxide emissions are largely global, not national, China has little incentive to consider them in its decision. The coal-fired plant would be chosen, and therefore the GEF would recognize that incremental cost and compensate China for it. Now, there are some controversies with the Kyoto Protocol. Emissions trading is not without its problems. Controversies range from such fundamental issues as the morality of global emissions trading to concerns about weaknesses in the implementation details. And the two big ones are the effective monitoring and enforcement of emissions. So how do you ensure that, a company says, oh, we'll simplify and we'll say 2 units of emissions. Well, they can lie. What are the authorities going to do? Are they going to sit over the smokestacks and record how much is coming out of the smokestacks? No, there is a sense of honor in the system, and there are a lot of people and a lot of companies that cheat the system. And so that's one of the big arguments against the effectiveness of the Kyoto Protocol. And also unearned surplus allowances. So first, greenhouse gas emissions trading will only achieve the goals of the protocol if monitoring and enforcement is adequate. Monitoring and enforcing international agreements is much more difficult than enforcing domestic laws and regulations. And two, we've already talked about this, due to the way that goals of the protocol were specified, some countries, specifically Russia and Ukraine, find themselves with a considerable number of unearned surplus allowances to sell, since protocol requirements are defined in terms of 1990 emissions levels, and emissions in those countries have fallen below those levels due to the depressed state of their economies during that time. So Russia, this was during the Cold War or post Cold War, and so Russia was not producing as much. Their industry wasn't really booming, and so they were suffering. And so the amount of emissions that was coming out of their economy was significantly less than what would have been on average if they were performing at a higher level. And once they exited that, they did find that, oh my gosh, I have much more emissions that I can sell, right? And so it is unfair in that sense. Now, also there's policy timing. The question of policy timing essentially talks about, okay, when do we actually implement these policies? So benefit cost studies of options for controlling climate change ignore uncertainties in the state of our knowledge, typically suggest a go slow or wait and see policy. This is due in part to 3 reasons. So the present value analysis results in overvalued costs and undervalued benefits, the initial capital cost of replacing energy generating using facilities, and the models anticipate technological improvements and lower costs in the future. So the use of a benefit cost analysis based upon the present value criterion in climate change discussion is controversial. Spreading the capital investment decisions over time implies that some investment takes place now as current capital is replaced. Furthermore, the expectation that future technical change can reduce costs will only be fulfilled if the incentives for producing the technological change are in place now. In both cases, waiting simply postpones the process of change. So essentially what this means is that when you're analyzing policies, the common analysis technique is the cost-benefit analysis, and you conduct a present value analysis, and you look at, okay, if we implement these policies now, what are the net benefits and what are the present value of those costs, right? And because the costs are incurred earlier on, whereas the benefits are incurred later on, it's unfair to value it in the sense, because really it would just, the net result would give go slow and wait and see. Don't implement that policy because there's more cost than benefits, even though we know in the long term that's not true, because the value of those future benefits, should not be discounted at the same discount rate, and that's another discussion. But that's really important to understand. And a newer model finds that a hedging strategy that involves modest reductions now dominates a wait and see strategy. Not only does current action initiate the capital turnover process and provide incentives for technological change, but it also allows the avoidance of very costly and potentially irreversible mistakes later on. Since emissions from the wait and see strategy would be much higher by 2035, the reductions necessary to meet a given concentration target would have to not only be larger, but also concentrated within a smaller period of time. So what are some ways to create incentives for participation? So, the big challenge, especially when, signing the Kyoto Protocol, was, okay, how can we bring more countries on board, especially developing countries, which, as we talked about, will suffer more from a cost perspective. Well, there are cost-effective programs, there's issue linkage, and there's the transfer from gainers to losers. So one strategy that has already been discussed is the use of cost-effective policies. It can positively affect the level of participation. Since cost-effective policies reduce the cost, but not the benefits of participation, those policies should make participation more likely by increasing the net benefits from joining the agreement. So talking about developing countries and the higher costs that they will incur, if you can implement cost-effective policies which will reduce those net costs, then the overall present value, the net benefit, will be significantly higher, and therefore encouraging participation. Another strategy involves issue linkage, in which countries simultaneously negotiate a climate change agreement and a linked economic agreement. Typically, candidates for linkage are agreements on trade liberalization, cooperation on research and development, and international debt. Another strategy for encouraging participation involves transfer from the gainers to the losers. Some countries have more to gain from an effective agreement than others. If the gainers were willing to share some of those gains with reluctant nations who have more to lose, the reluctant nations would be encouraged to join. Other than that, that's pretty much it. That will be my final video for this video series. So as I said at the start of the video, if you are interested in me releasing more videos, please comment below and let me know that you want more videos, and if I get enough demand, then I'll publish more videos as well. Other than that, as always, please check the video description for a link to the Amazon page where you can buy the book. I'm working off the 9th edition of the Tom Tietenberg Environmental and Natural Resource Economics textbook. And as always, please show your support by liking the video and subscribing to my channel for more videos. As always, good luck with your exams and have a nice day, guys.